Hello friends, welcome back. One thing I like to do if I can is to provide examples for you to see practical ways of applying some of this statistical knowledge. A lot of us will look at a textbook and try to solve problems that are packaged very prettily in a problem on a page with all the data right there. But it's been my experience that the real world doesn't quite provide such simple problems to work with. So I do like to try and give you some exposure to ways you can actually take these tools and apply them in the real world by using some reasonable assumptions that we make as leaders in business, and hopefully this is an example to give you for that. So piggybacking on our last discussion about variance and standard deviation, let's suppose either your boss or supervisor, or maybe you as a business owner, is considering about hiring some sales professionals to help do some of the promotional activities of your business. And you are probably, maybe let's say you don't have a lot of capital. Maybe your small firm doesn't have a lot of staff to do a high level salary analysis to determine pay grades, good salary ranges. Well, if that's the case, I think it's a good idea for us to maybe use some of the tools we're building here to do a quick and dirty way of trying to estimate a salary range. So here's what I've done. I have gone on to salary.com and pulled in a table or a curve or a distribution here for a basic business development associate. We have here the median value in the middle of this peak. We have the 10, 25, 75, and 90% salary levels for this particular position. I've marked them on that chart A, B, C, D, and E. And next to it, I have put them in a table, and I have back calculated the Z value. Now, I'll get that here in a second here, which corresponds to a statistical location along a normal distribution curve. So what is that? Well, if you recall from your reading that a normal distribution curve basically tells you the probability of something having some variance away from a mean value. Now, a normal curve has a symmetric distribution, and the various measures of central tendency, the mean, the average, the median, the middle value, if you put all of the numbers in sequential order, and the mode, meaning the most common value in the distribution, in a symmetrical normal distribution curve, all three of those values are the same. So we're going to try and use this information here on this table, or on this chart, to see if we can build a similar curve for our salary ranges, and if so, that'll help us structure some a reasonable set of ranges for salary, just to get a good rough, quick and dirty estimate of those ranges. Now, I want to remind you from your reading what the z-score equations are. So here is the equation here for z-score. Z is equal to x, which is your observation, minus mu, which is the mean, over the standard deviation. Now, for those of you who are not familiar with z-scores, there's tables like this one here that are all over the internet. You can do a quick Google search for a z-score table, and you'll get any number of these that you can download for your purposes here. But for each of these z-scores, we have a certain probability of that occurring. Now here, as you can see up on this curve, that at the 10% salary level is this dollar amount, and that 10% is a measure of the tail. It's hidden behind this thing here, but it's the tail It's this probability here under that tail of the graph. So it's from here all the way to basically negative infinity. Now, so and that if you were to take a fraction of it, this volume or the space on this table or the area on this part of the graph is 10% of the whole curve. So the probability is just a table of probability. This is at this number here, 10% of the salaries are going to be less than this number here. So we're trying to figure out what z-score is. You get your table out here and you find these all here are the probability values, and here is 0.1003. This is the probability of roughly a 10% or value. At that point, you go ahead and you go to the axes of the graph here to find what that z value is. So starting with 10%, we come over here to its negative 1.2. And then you follow the top line here over to the 0.08. So this is a z value of negative 1.28. That's where that comes from. So that's why I plugged in here. And I've done the same for all of the 10, 25, 50, 75, and 90% values. And I plugged in all those values here. Okay, so now we have a rough idea of z-scores. We're actually in the process of back calculating the normal distribution for the salary. Now, if this is a true normal distribution, this would be symmetrical, meaning that in this case, C minus B would be equal to D minus C. Also, C minus A would be equal to E minus C. So the question is, I've done that test there, and we see that if this was a perfectly symmetrical curve, both these numbers would have a difference of 0. And that's not the case here. And honestly, that makes sense, doesn't it? Because if you think about a range of salaries, there is a hard bottom to the curve. You can't be paid less than $0. And honestly, when you, due to minimum wage laws, things of that nature, there's probably a lower bound to what those scores would be that's greater than 0. But let's say, for example, for a sales professional, in theory, there's no limit to the higher level that people can earn. So some folks can make hundreds of thousands of dollars a year through big commissions, etc. So if you have a hard bound on one side and an unlimited bound on the other side, then this is a tendency for data to accumulate on this side of the graph much more than this one. So this is called a skewed distribution, where the distribution is skewed to the right. So this helps to justify why we're having this answer here, that the data does appear to be skewed. And of course, the difference here is larger than this one, because this is looking at includes the outliers. So it's saying that 90% down to the middle relative to the middle down to the low end. This is probably more confined than this end, but there may be some real stellar high performers which pushes this guy, this E, even further to the right. And that's going to be a larger disparity than, let's say, from D down to C versus C down to B. So I hope that gives you a bit of idea about how this data is skewed, and see how we can maybe still use it anyway. So if we know that the data is skewed, which is just telling us maybe this is not the best use of using the median score here, 61,472, is not the best measure of the mean, because it's probably, the mean score is going to be a little bit higher than what the median dollar amount is here. So let's go ahead and see. Let's take an average of D plus B. So basically I'm taking B and D and I'm averaging it, because hopefully if this is the mean would be somewhere in between B and D. hopefully right down the middle. Similarly, it would be right down the middle between E and A. So I'm taking an average value between those pairs, B and D and A and E, and we are finding that these are the values of the average between those two, so that might be a closer value of mean. And again, as I said before, that the A and E are probably more the outliers. So if you stay within the central zone between D and B, that's probably a better measure, a more common. There's fewer outliers in that area. So if you take the average between those two numbers, that's probably a better estimate of the mean. Okay. So I'm going to call that no longer C, but C prime. So I'm going to take whatever this average salary here and mark that C prime. So I'm going to go ahead and do that same exercise about the differences. And lo and behold, if you take C prime minus A and compare it to E minus C prime, and similar for C prime minus B and D minus the C prime, we can see that the differences have gone down. This difference is going to be is equal to that minus that. So this is the outlier at about 3,000. But here, this is the difference between the central values there, and the difference is identical. So this is very good evidence that our back-calculated estimated mean is a very good estimate of the mean for this set of data. So now we have a mean, we have points on the distribution curve. Now all we need to do is figure out what the standard deviation is. So we now have the z-score equation. We have one equation with one unknown because we know what x is. If we plug in one of these numbers, we know what the z value is from the table. We have the mean score. So solving, we by doing basic algebra, we transform this z-score equation to a equation for sigma. So now our sigma by solving is 15,559. Okay, so our takeaway here from this back calculated score is that we have a normal distribution approximately with a mean of $63,046 and a standard deviation of 15,559. So now we can take this information to build a set of salary ranges for our various levels of performance for new sales professionals. So here we are. We'll start with, we have 4 categories here. We have an entry level or a marginal performer who has a standard deviation, about 1 standard deviation below what the average value would be. The average performer will be at standard deviation of 0. An above average performer is one that has a 1 standard deviation higher level of ratings than the average individual, and a superior performer would have 2 standard deviations of performance greater than that of the average. So these are the z-scores for those various levels, -1, 0, 1, and 2. If you take this here, we can do a forecasted salary by taking the mean, and then you add in the z-score times the standard deviation. So in this case, it's 1 negative standard deviation times the from the means. You see the equation here. It basically works out to be this 63,046 plus the -1 times the 15,559, and that gives you 47,487 as the average value of a entry level or marginal performer. Same goes for each of these various other ones. You can see a superior performer which has performance ratings 2 above the standard deviation or 2 standard deviations above the mean would have an average salary of $94,163. Okay, so we have good estimated values, but to establish a range within those categories, we will then have a range that will start at -1/2 half standard deviation below to 1/2 standard deviation above that predicted value, and that gives us a good range for negotiation. So an entry-level performer would be hired somewhere in the range of $39,700 to $55,300, and a superior performer would have a range roughly between $86,000 and $102,000. So you can see, although this is a longer video, it was actually a pretty easy set of calculations to run through. You could have gotten through this exercise probably within about 10 minutes if you had thought through this stuff ahead of time. So you can see how powerful these tools can be by picking up. We started with a diagram that we downloaded off the internet, and within 10 minutes we actually built a whole plan, a plan grounded in actual data, non-arbitrary, and that would really help to connect our salary ranges to what the market has to offer. So we're not going to be overpaying or underpaying potential candidates. So in short, I hope that you have found this video to be useful and you have a good idea about how powerful these tools can actually be used to solve real-world problems and do so quickly. And I will see you in the next video.